We did not finish 6.2.
Oh.
At the back of 6.2, there's a lot of problems that still have to be gone over.
6.2 is.
Kind of like the warm-up that we did today. We did go over that one, but now we're going to do the same thing according to the y-axis. Use the washer method, find the volume of a solid. Basically, inside minus, or outside minus the inside. Find the volume of a solid generated by revolving the region enclosed by the graphs. So this enclosed, what does that mean? It's a really important statement.
What's inside?
Between them, right? So that means that these two graphs touch somewhere. And so that's what we're looking for. So the two graphs are going to be touching somewhere. So I need to set them equal to first to figure out my bounds. So 2x equals x squared. And whatever you do, do not divide everything by x to get rid of one of your values. Because that means that if you do that, you're going to get rid of one of your factors. You don't want to get rid of them. You want to find what they all are. Okay, so I'm going to move this over. So 0 equals x squared minus 2x. Now, divide both sides by, or no, factor out an x. X minus 2 equals 0. So now my factors, where these two are going to intersect, are going to be x equals 0 and x equals 2. Are we okay there? Yeah. Okay, so now that's important. Now I have my bounds there. Since this is going to be a revolution, this is volumes of a revolution, I'm going to take this information and I am going to set this with my bounds. Now, I know that my cylinder, let's start with pi, it's going to go from 0 to 2, and it's going to be from, okay, the top minus the bottom, right? Mm-hmm. So find a number in between there, so I got to figure out where's going to be the top. So I plug in a 1, because it's between there, so it's going to be 2x is going to be the greater one. So 2x squared, right? So a couple different ways of doing this. You could actually do this as this function and then minus the next function, or combine both functions. So I'm going to combine both functions. So minus the bottom, which is going to be my x squared dx. All right, I want you guys to do that real quick, please. Work that out. All right, let's see what we get. Okay, square first, right? So pi 0, 2, 4 x squared minus x4 dx, 4x cubed over 3 minus x5 over 5 from 0 to 2. 8 times 4 is 32. over 3 minus 32 over 5. Common denominator. This came out just like our warm-up.
It's kinda like just
54 over 15.
64.
64 over 15. So
That's what I did. Oh, yeah, it's the same thing. It's just this.
64 pi over 15. Are we okay? Good. So it's the same thing. It's actually
I'm just confused as to
what's what?
about the pie part.
The pi? Okay, remember when we were talking about, I'm going to show you. So I'm going to have this is a cylinder, right? The volume of a cylinder, pi r squared h.
Yeah.
Okay, the volume of this cylinder. So to go from here, my pi, which is going to just go in front, my bounds is going to be my h. And that's going to be from this point from A, this point B. And that's going to be how tall my cylinder is, right? That's the height. And that's from A to B. And I still have to deal with the radius, whatever the radius is. So if this was a basic cylinder that the sides are the same, or are straight parallel lines, then it's whatever the radius is, and it's going to stay the constant the whole way. But the problem is we don't have a constant radius. We have a changing radius. So it's going to be whatever my function is. So it's going to be f of x, whatever my value is there, squared delta x, because I'm actually going to do this in terms of x axes. So breaking down the whole formula, it comes out all like that. Okay, so now we're going to work this out the other way about the y-axis. So we did it according to the x, now let's do it according to the y. So we know that it's going to be like this. So we're doing the same thing, but now, since my points are the same, but I'm not going to rotate it this way, I'm now rotating it this way. So that changed the shape of it now, right? This is now a bowl, right? It was a weird shape in the first place, now it's going to be a bowl. So now as a dy, I still have that it's going to go from here to here, right? Here to here. But now when I set my 2, so it's 2x equals x squared, right? And I go 0 equals x squared minus 2x, x quantity, x minus 2 equals 0. But now these are all my x-axis, right? So what do I have to do this in terms of the y-axis? Plug those in to see where it's going to be at, right? So I know what the x points are going to be. Just plug it in and figure out what the y points are going to be now. So I got where my x is, right? So when x is 0 and x is 2, all right? So now let's plug in 2 for that. So it doesn't matter which one because they're both going to be the same, right? Yeah, so 0, so I get 0, 0. So I get y is 0, and I get y is 4. So now that is my integral, right? So I now have my integral from 0 to 4. There's my pi. Now, I'm gonna do a dy on this. So that means I need to have all my terms in respect to the y-axis. So I'm gonna change this now. So now this is going to be y equals x squared. So that's gonna be x equals square root of y, right? And this is gonna be y equals 2x, and now it's going to be y over 2 equals x. Yes?
Wait, where do we plug in 0 to find y?
Oh, either one. It's either this one or this one. Those are both my functions, right?
Okay.
Yeah, those are my both functions. So plugging in here, 0, I get 0. Plugging in here, I get 0, right? Same thing for here. Plug it in here, I get 4. Plug it in here, I get 4. Yeah? Okay, so now I'm going to clean this up a bit. So now, let's take a look. So I'm going to have the outside minus the inside. So the outside is going to be the square root of x, right? Square root of x. So it's going to be, square root of y. So it's going to be y to the 1/2 squared minus y over 2 squared dy. Alright, so let's now do our math on this. So I'm going to go pi integral 0 4 y minus y squared over 4 dy pi y squared over 2 minus y 3 over 12 from 0 to 4. So I want you to do this part.
Okay, it's my friend, so I'm gonna do this.
Okay, so let's see, we're gonna get 16 over 2 minus 64 over 12 and minus 0.
It's 8 pi over 3.
What is it?
8 pi over 3.
Okay, so 8 pi over 3.
No, I didn't.
That's fine. No, if you have to do the calculator part, it's fine.
Yeah.
I can't.
That's what you told me.
Okay. All right. So now, we just did this according to the y-axis. Why is this different? It's a rotating different axis. Is the shape of my volume, is that now different too? Yeah, that is now different too, right? So this is now going to be a bowl. This is a bowl, and so the volume is going to be different. So if you do it according to the x-axis rotation or you do it according to the y-axis rotation, it is going to be different because it gives you a different shape. So whenever you see problems like this, you're like, oh, I'll just do this to the x-axis. No, you can't. You have to do it according to what it asks because it's asking for a certain shape. And that's important. All right, find the volume of a solid formed by revolving a region about a line parallel to a coordinate axis. Now, this next one here, these are the ones that you will have on the AP exam. They always throw this in there. They always do. These are the hardest types of problems for these. They're not going to give you a basic. basic volume, they're gonna give you one of these. Now, whenever you do something like this, you need to always try and figure out your radius is what you're looking for in your formula. Bounded by the graphs, so I said bounded by the graphs, so what do we say about that? If it's bounded by them, it means that they're equal, right? So it's enclosed in there, it's equal about the line y equals -5. Okay, so first, let's take a look at this. So 2x equals x squared, right? So 0 equals x squared minus 2x. So x and x minus 2. Okay. So I get x is 0 and x is 2. Now, this is the important part. It's about this line right here. So I'm going to go through and I'm going to sketch what this is going to look like. And I highly recommend you do the same thing.
But this is just gonna be rotating around this line instead of y-axis
Yes, it's not around the y-axis
or x.
or the x-axis. It's about some other line.
No, I'm not. She said he, and you thought it was he.
But I mean, if it's like y, it's gonna be still this kind of the same.
Wow, that was a lot of pronouns.
He, she. I said a he, she. It,
He, she?
It can move it in one.
it's okay. People say my gender all the time. And I'm wrong.
Isn't the volume gonna be the same though?
No, it's not.
If it's around x-axis?
No, it's not.
You're good.
But why?
You're never in
Why is it not? You'll see in a second.
Oh, it's mine.
So, I'm going to change color here.
Yeah, that's
If the graph does not exist below 0,
no.
like the line that
Don't touch me.
x squared does not.
All right. Now, this is what I said to do. I said to graph it, right? We're going to do everything exactly the same. But I want you guys, when you graph it, you have to do this step because otherwise it is going to mess up everything. It's going to mess up everything here. So, I am rotating around the line y equals -5. That's what I did right there in black. So, I'm going to start off, I have pi, bounds, 0, 2. Now, my radius is going to be about this, so it's going to go from here all the way up. So that's the radius of this. So the radius is going to be, how would I mark that as my function? How would I mark that as my function? How would I be able to mathematically say my function is this?
Oh, we just need to change. It's like x is equal y, or x is equal, like,
You're on the right path.
I mean, like, if we wanna move it down, then.
We're not moving it down. We're not moving it down. Our function is still here, right? Our function is still to this point.
Just -5 plus the function value?
No, because that -5 is going to miss.
Just 5, I mean, because if we count the distance.
Yes, very good. That's what I need. Exactly. So you have your function, right? Because your function normally gets you from the x-axis up to your line, right? From the x-axis up to your line, but we're going to add 5 to that. And that's going to give me what I need for the volume because it's going to give me my radius that I'm looking for. So in this case right here, I'm going to have that it's going to be my 2x plus 5.
So we do the same for x.
And you're going to do the same thing for the other one, right? Because it's going to be the outside minus the inside. So I'm gonna have you guys be doing this math here in a moment. So we have that one right there. So there's my radius, right? That's everything I'm trying to get you guys to do. So if you could sketch what it is supposed to be, it'll give you a picture, be like, all right, so now I need, my radius is that. So minus my other one, which is gonna be x squared, right? And I'm gonna do what? It's gonna be from here up, right? So it's gonna be x squared plus 5. Now I want you guys to do this real quick, please.
If it was y is equal to 5, not negative 5, is it still gonna be plus 5?
You have to sketch it. You're always gonna have to sketch it.
Like if this line was just like positive 5, not negative. Like the same line. The
So
line
you're
was-
saying on the same one,
Yeah, but that line, the negative 5 is just on top, so it's positive 5, not negative 5. Is it in the equation? Is it gonna be plus 5 still or minus 5? Like 2x minus 5?
it would change because it would be the function 5, right?
Oh, top. Okay.
It'd be 5, and then it would be to the next one. It would be going down, wouldn't it? Okay, so it would be of the top, which would now be the bottom one here, right? So it'd be 5, whatever it is, minus or plus that, right? It'd be minus because I'm taking off whatever my value is there, right? That'd be minus whatever that is. And then squared, then minus my other one, it would be 5 minus my inner function. If you sketch it, it makes so much more sense. Every single time, sketch it and draw out your radius.
What if it came out negative? The answer, like negative 12 pi over 5.
All right, let's see what we get now.
I got 64.
I got 70.6.
You got what over what?
64 pi over 15.
64 pi over 15?
Yeah.
Okay, anyone else?
I got 70.6. Just a second.
Did you guys have an answer?
78. Yeah, 70.
All right, let me see what we get. So,
Yeah, 88 over 5 pi.
4x squared minus plus 20x plus 25 minus x4 minus 10x squared minus 25. This is my dx. Pi. This is gonna be ugly. Oh wait, no, that goes away. Let me get 4x cubed over 3 plus 10x squared minus x5 over 5 minus 10x cubed over 3 from 0 to 4.
4.
2. Whoa, crap. Wow, where did I get that from? Yeah, I'm sorry. Brain's starting to melt.
It's okay, it's a big mood. That's me, that's me every day. Same.
All right, let's see. We have uh, 8 over 3. 5 minus 80 over 3. I got 88 over 5. 88 pi over 5.
This is,
I got
this is
64
right,
over
Master.
You got that?
Yeah.
Let me double check real quick before I, say he's wrong.
I guess it's well.
Yeah, it's 88 pi over 5. So let's check your
Oh,
work.
wait, you know what? No, I get one.
Why?
I think.
Did you do 4?
No.
Are the signs?
I think I just didn't add the, I don't know. I don't know why, but it's okay.
Is your signs the same?
No, that's fine, probably.
You did not FOIL the middle terms. You're missing the middle terms on these. What did it say, 88?
Yes.
It's not too bad, right? Not too bad. And I think I have 2 more examples for this.
One.
I got 1 more. All right, so this is what it's gonna look like.
Yeah.
This is what the,
Two more.
There's a picture linked.
there's 7. Yeah, just 7, just 1 more. All right, I'll save this for tomorrow. All right, don't forget, like, share, and subscribe.